Afternoon, everybody, and thanks for joining Tevora's webinar, Tackling the Security Challenges of Modern Cloud Operations. I'm Kevin Cutter, a Cybersecurity and Compliance Advisor for the Tevora Information Security Management Consultancy. Joining us this afternoon is Chris Callis, Managing Director of Tevora's Cloud Security and Compliance Practices. Before we dive in, a few details about us. Tevora is a peer-focused information security. As a premier management consultancy, we've executed services exclusive to the InfoSec space since our beginnings in 2003. Tevora has 7 dedicated practices to information security: cloud security compliance, threat management, data privacy, cybersecurity framework compliance, incident response, enterprise risk management, and solutions implementations. Our practices support several hundred cybersecurity and compliance services. Each one is overseen by a principal, with managing directors, practice leads, consultants, and associates reporting up a chain of command. We have a dedicated project management team. That team is assigned to all client InfoSec projects. They're tasked with meeting any identified deadlines or requests. Tevora has a 17-year refined methodology to information security, is ISO 27001 certified, has over 100 information security professionals, 0 contract employees. Our team service the entire US, and many of our clients span the globe. We have offices in California, New York, and Virginia. Year over year, we've grown organically at a pace that ensures we bring quality and expertise that a lot of our repeat clients have come to expect. As we get started, you'll note we're allowing for questions. These will be addressed by Chris when he wraps his presentation. We find questions from your fellow InfoSec professionals yield fruitful insights for the others that are tuning in. So please ask away. With that, I'll turn this over to you, Chris.
Thanks, Kevin. Appreciate it. So, hey, everybody. My name is Christopher Callis, and I'm head of cloud security over here at Tevora. Today, I wanted to talk to everybody about something near and dear to my heart, and that is managing security complexity in the modern cloud workload. You see, it's not that one architecture is better than the other. It's deeper than that. Today's workloads span multiple specialized fields that have to address various regulations. And this means you have various kinds of individuals that specialize in their particular area of operations. Networking, systems, security, applications, front-end stuff, back-end stuff, storage stuff. You get the point. In order to understand how to manage this complexity we have to deal with today, I need to take you on a brief look at how operations has evolved over the years. In the beginning, organizations had one data center with a single server that famously took up the entire room, called a mainframe. This required teams of people to manage, and a lot of this management was done at the physical layer. Vacuum tubes, tapes, lots of mechanical parts, lots of maintenance. The next step the industry took was this transformation from mainframes to servers. You go from a room-size calculator to a single rack. It was sexy, sleek, still relatively easy to manage. Most large organizations would have many of these. They were much easier to maintain, and each server generally served a single function. But the world got bigger, a global connected economy. The need to have interconnected systems across the globe became a thing. We had to start to tackle regulations and serve different content based on the country it was being served in. We'll talk about the rise of the co-location data center, both for disaster recovery purposes and the ability to really drive traffic as close to the edge as possible. This complexity evolved, and it started to become very clear that it would soon become impossible to manage by hand. Engineers had to fly to different locations to manage these servers, or you had to synchronize teams across various time zones. Additionally, if you took a look at the resources being used, you generally would see maybe 10 to 20% of the CPU and 5% of the memory being used. Then came the hypervisor. Instead of a single application on a single server, you're able to virtualize the operating system. There was a layer of isolation that didn't really exist up until this point. So now you can isolate multiple systems on the same machine and take advantage of the additional resources that were previously untouched. This led to a dramatic increase of systems. We went from thousands to tens of thousands overnight. Now you're running systems on shared hardware, and there's tremendous reliance on isolation in the operating system layer. This required a huge team of people. Automation went from a nice thing for the future to being a necessary requirement right now. Configuration management tools like Chef, Puppet, Ansible, and Salt were developed to manage the complexity of the individual system, virtual machine, or server. And tools like Terraform and CloudFormation allowed organizations to manage the complexity of the modern infrastructure. This allowed engineers to use declarative code that allowed consistent enforcement across all systems and networks. We live in a world where tooling is no longer an optional thing, and there needs to be a strategy to enforce consistency across these complex environments. And time again, the way that we see organizations tackle this issue is through code. More specifically, codify their environment. And when I say this, I'm talking about capturing that routine process configuration in a form that allows it to be repeatable and scalable. Now, there were a couple of ways to accomplish this at a high level. Code can be declarative or it could be imperative. Think of imperative code as the traditional procedural object level type programming like C and C++. This way, the code gives a step-by-step process on how to accomplish that end states. But it's still kind of hard to read for people that aren't, software developers. With declarative code, we are specifying the desired end state and letting our tooling decide the best way to achieve this state, regardless of how it gets there. I really love this. Not only is it easier to digest and validate from a security and compliance perspective, it means I'm not locked into a single platform and that I have the capability to spread my resource across various kinds of infrastructure using the same tooling with just needing to swap out a module and point it at a different environment. Now that we have some of that out of the way, and I have everybody on this webinar on board with 100% commitment to adopting declarative codification of your entire workload, where do you start? Well, let's start with what we call configuration management tools. Regardless of the tool you decide to go with, they are great at managing the complexity of a single machine, operating system, or virtual machine. These are tools such as Salt, Chef, Puppet, Ansible, and each has their own corresponding Salt state and pillars, Chef recipes, Puppet modules, Ansible playbooks, and in these modules you specify the condition of the system, and depending on the mode that you have these tools running in, they will apply the state throughout the environment. So we talked about configuration management tools. Great, your systems are all hardened. Work here is done. Kevin, feel free to end the webinar. Nah, I'm just kidding. Like we discussed, environments are way more than just a single system now. What do we use to manage the complexity of the rest of the workload? Well, let's talk containers, Docker to be specific. I personally love containers. Containers are great because they are immutable. This means that they are stateless, just a number that is used when it is needed and disposed of when the time is right. Gone are the days of naming systems after your favorite significant other, pet, car, city. The configuration files are declarative and the containers are immutable. This means if there is a vulnerability in a dependency of a container, Docker's vulnerability management will notify you, just like with code. You change the one line to a non-vulnerable version, push, merge with the master, and deploy it out to your environment. Even better, leverage a CI tool. Once the change is committed, it will be automatically deployed. No more logging into each system, having SSH exposed, and typing apt-get dist upgrade on those tens of thousands of systems. How about the infrastructure side of the house? Tools like Terraform and CloudFormation can be leveraged to manage the complexity of infrastructure at scale. Landing zones are becoming commonplace, and these environments are starting to be used similar to containers. Spin up a new account that is identical to production VPC, test and dispose of it when it's no longer used. We found that the greatest way to ensure segmentation in the cloud is at the account level, and these tools are vital in ensuring consistency across all environments. And then we have the continuous integration, continuous delivery type tools like Jenkins, GitLab, CI, and Concourse. These tools ensure there is continuous integration on code that has gone through the internal approval process. These are amazing tools that allow organizations to enforce their own opinion on their environment at a code level and is key to that version controlled workload that we all desire. So now that we have an understanding of the tools that exist and understand the mass codification, it's clearly the way to manage this amount of complexity we've all been experiencing in our workloads. Let's dig into why there's a tendency for organizations to embrace code with things when things get complex. Linting is one of the reasons. Once code is captured, linting allows an organization to enforce their own opinion on that code. This is commonly done in the form of static analysis and alerting. And in these organizations, they can go as little, as deep, or as complex as they want on their code. A lot of the times, when we hear feedback about false positives with static analysis tools, and people just ignore everything. But there's other ways to approach it as well, like scanning the code for, hard-coded credentials versus using something like a parameter store. Another advantage of codifying everything is collaboration. Codification is the huge benefit here. Once code has been captured and all teams are speaking at the same language in a common format, we can then all build out processes to pull, push, change, merge our code, and then we could leverage these CI/CD tools and processes to automatically build a workflow that works for and supports collaboration. This code collaboration is a huge driving force for adoption. With the increased complexity in our environments, it's difficult for a single person to reason about in the environment alone. Collaboration provides those checks and balances and keeps teams on the same page. And version-controlled infrastructure drastically helps manage security and compliance requirements. It also allows for a separation of duties. These tools have a lot of modular options, salt states and modules, chef recipes. There's an intrinsic layer of isolation that allows us to define our problems within our respective domain very specifically. The world doesn't need to be solved, just our tiny corner of it. I joke about this with our clients all the time and talk to them about treating workloads like Legos, picking that right 8-dot piece to fit their particular workload needs. So once all your code is captured, my favorite thing to be able to do is model the output. This allows us to take these abstract concepts like infrastructure and networking and input them into something that allows us to interrogate our design. For example, Terraform allows you to output the format into a dot file. And you could take this file, which is an open source format, and leverage academic tools like GraphViz to 3D visualize the world that was just architected. So what's next in the future? If we look over the horizon, there are going to be multiple trends we have noticed as organizations adopt this codification of their entire workload. The biggest change is the adoption of version-controlled workloads. One of the main security principles of well-architected is keeping people away from production and data. If you take a look at the cloud breaches that have occurred, most of these were misconfigurations in S3 buckets or reused credentials whose configurations deviated from an improved format because the environments were manually configured. Codification and hardening of the CI/CD pipeline allows change to be done as code. That means if there is a security vulnerability or a misconfiguration is discovered, it should be remediated as code in the respective code repository, going through change control and linting and not by SSHing to the machine and running apt-get dist upgrade. The next thing we're seeing, which is really exciting, is this proliferation of automated reasoning, or some call it provable security. This is a really exciting field where a lot of these cloud service providers are mapping their services to quote math language, allowing you to integrate your configurations with questions like, is my database that lives in my private subnet accessible to the internet? These tools use math proofs to answer your questions without sending a single packet throughout the environment. Deep insights or deeper insights, depending on how you look at it. So today we have the capability to perform vulnerability scans. These are great, right? Generally, these reports shoot out a bunch of CVEs that existed 10 layers down in the workload, telling you that it should be updated. This is good. You get an email or a report is generated letting you know that there is a vulnerability. Then the team gets dispatched to go and patch applications, praying that production doesn't break. How many of you guys have been worried about breaking production when updating? How many of you are comfortable with automatic security patching? Right now, as it exists, you can use AWS Inspector to perform scans against your EC2s, kick off a Lambda function if a CVE hits a certain level of criticality. But I feel still this technology is still not in a mature state where teams can rely on it with confidence. For some really neat challenges in this field, I would recommend that everybody check out the DARPA challenge from DEF CON 24. This challenge had to do with automated vulnerability scanning and patching, but it wasn't just doing a periodic scan. These systems would identify if a certain service was actively being exploited and automatically fix and patch the vulnerability without being pulled from production. When the software does become more mature, how many of you are going to be comfortable with letting it run wild in your environment? How do you know it's not going to go all Dolores on your workload and decide that the whole Skynet approach is indeed the best approach? So we're seeing this cultural movement where mature teams are shifting their roles from putting out fires to causing fires to understand their environment's weaknesses. Netflix had a famous group called Chaos Engineering. These teams were confident in their workload's ability because the workload has been designed to be scalable and repeatable, and there was no nuances from one location to another. And this consistency is what fosters confidence and adoption. We're seeing tools like TensorFlow in operations, but it's no longer performing the usual AI machine learning stuff that we all joke about, like, is it a dog or a hot dog function, It is being used to analyze logs and metrics to pick out that needle in the haystack. Remember, these environments are now tens of thousands of times larger than they used to be, which means there's a lot of logs to digest. Another piece of technology we're really excited about is distributed tracing with technologies such as OpenCensus, which understands the flow, the traffic from the internet to your microservice. This can point out things like a bad deployment, but it can also be leveraged to understand if there's a malicious individual within your environment. So we talk about why the codification of the workload is so important. From a security side, I'm excited to see what Security Engineering 3.0 has to offer, but this isn't going to happen until we embrace this whole concept of creating fires rather than just putting them out. And to get there, I think the vital step is to have that consistency in our workloads. Embracing code is everything, embracing automation and challenging the ways that we secure our environment. My name is Chris Callis. I'm head of cloud security over at Tevora. Here's some of our contact details, and that is it.
Great. It looks as though we do have a few questions before we wrap up. So one of the first ones, Chris, was, is there a configuration management tool that Tevora recommends to its clients?
I don't know if it's because I'm partial to SALT, because it was probably one of the first things that I ran into from a configuration management side of the house. I really do like the whole SALT stack thing. You could use it as a configuration management tool. We're able to do it as like a serverless type function, but all of them are great. And I don't see generally an organization adopting one over the other. It really comes down to the technology that they're using. Are there modules that support the technology that they're using? And, how quick can the team really get up, spin up on the new tech? What I would recommend is, if you're looking at adopting one of these, definitely pick out one, and they should all do it. I'm not an expert in all of them, but generally they all adopt this whole concept of declarative programming. So you could state, hey, we want to see these users. Hey, our files should be configured with these values and hardened to a certain state. So if it is declarative, that's a big, thumbs up from my end, because generally there's a module so you could swap out things like saying, hey, on our on-prem infrastructure, we have this hypervisor. Okay, so there's APIs that exist and we could point our environment there. Or if you're using AWS or Azure, they have their own APIs as well, and you swap out one of their backends on those configuration management tools, and you could start deploying, spinning up systems and hardening them to your heart's content. Good question.
Oh, great, good answer. And then it looks like we have one other question. How do we get our teams to embrace these concepts that you're presenting on?
Yeah, that's a multi-tiered question, right? I think the first is, everybody goes through their training and stuff like that, and it's maybe pointing them to a configuration management tool. We found a lot of organizations adopt it just by, hey, let's take a look at this one system. Let's see if we can manage the state, and then teams start to quickly really adopt it and use it to really scale, their responsibilities, which is pretty neat as well. The other thing is, if the teams are in constant firefighting mode, there's not really an opportunity to explore some of these new technologies, if production keeps on breaking. So, we've gone into a lot of organizations where, there has to be like a 99.9 to 999, type uptime. But in reality, if something does go down, a lot of the times the user is going to be pointing the blame at their ISP rather than your workload before it gets remediated. So, allowing a little bit of tolerance with some of those availability things as well allows, teams, engineers, operators to really explore, the capability of some of the stuff that they just built out. That's a awesome question.
No, definitely. Again, great answer. So from what I can see, that's it from a question standpoint. So great content, Chris, and a big thanks to our audience for these 2 questions and for your time today. Tevora is an InfoSec services org, is pretty much prepared to help you and your teams wherever you guys desire. A lot of uniqueness going on out there in the marketplace right now. My colleagues and I will be reaching out to all webinar attendees, just ensuring that you received what you were looking for from Chris's presentation. We'll be able to provide the webinar deck that Chris has worked on, as well as an actual recording to this presentation for your files. You can share among colleagues or anyone else. So with that said, please enjoy the rest of your day, your weekend, and please keep safe. Thank you all. Bye-bye.